Hello everyone. This is my tutorial for the minor project, and mainly what we're going to do starting from week number 9 is just take you through some of the sessions to explain to you the outline of the project and also give you some advice about the manufacturing processes for the part uh, for the artifact you selected for your project. So I will go first with the minor project outline. As you can see here that we have the mini project outline, again to open that here. And also again to show you some example of the parts we're going to talk about, which mainly going to be the starter for the car. And yeah, also I have another thing which is going to be the water pump. I like to have the water pump for the cars. Um, where did I put the water pumps for the cars? The projects. It's in the project water pumps. Oh yeah, yeah, I had the water pumps here. So I think that the best photo we have for the water pump, well actually I haven't been here before for a long time. uh we'll come back to this one later. We'll come back to this one later. Okay, so I'll go back once again to the I'm sorry, I'll go back once again to the car starter, and we're going to explain briefly what we need to do with the pump. So, I'm sorry, just give me 1 second. Yeah, sorry. Yeah, so I'll come back to this one later because I think that I need to describe what will be the water pump components, because that's what I used actually to explain last year for the student in and their project when we talked about the DFX, or design for manufacturing processes and other stuff. Um, So what we can see here for the starter, that we have the pinion, we have the field winding, we have the commuters, the pushes, the actuating arm, and we have the return spring. Actually, no, I need more details about that, so maybe this one can do it. Oh, the problem is that I don't remember the parts for the starter, but I do remember the parts for the water pump. So maybe I will go with the water pump. Okay, so first, if you want to know what the water pump is, this is the part in the water pump, in the car, the water pump is recirculating the water that we use to cool down the engine during the operation. Um, you know that we have a radiator in the front, and what's happening that we use the water, the cooling water, to circulate it between the engine block and the radiator. And this can be done by a mechanical part, which is called the water pump. So the parts of the water pump can be shown in this engineering drawing, and actually you need to provide something similar to that. It does well. Actually, you can always find online, and if you cannot find this, simply you can make your own engineering drawings either as using the photos, or I mean, if you're going to have the actual part, just take the photos for it and try to fix the part together and show describe the names. Uh, this example, that's the one. This actually can work, but let me check the other one. Ah, yeah, yeah, yeah. Now this one actually is going to be the best one I can use for description. So for the water pump in general, we have the flange where the actually the pulley is going to be sit on, and this will be actually uh, cause the rotation of the whole pump to recirculate the water in the car engine. Well, I know that we will that. We have the main body, we have the mechanical seal, we have the bearing, and we have the antilles. So in general, the bearing is going to be off-the-shelf item, so you don't have to worry about it. But if you're going to analyze the other parts like the flange, the body, the mechanical steel, once again, it can be an off-the-shelf item, and we have the impellers. So at least the flange, the body, and the impellers are going to be manufactured by ourselves. So let me check the camera, and I'm going to write down, for example, how to manufacture each part by multiple methods. Now we're going to talk about first about the flange. Maybe we didn't mention something about, sorry, we didn't mention something about the shaft. We have shaft here. The flange is going to be connected to a shaft. So basically, in this example, we're going to have four parts. Okay, the flange is going to be the fourth one. So we have the flange, we have second the shaft, third we have the impeller, and fourth we have the body. Okay. Now, by simply checking these parts, we can say that the flange has been done by mainly machining. And this machining, of course, going to have uh, from the part we serve, we have to do the turning, and we need to do either the milling or the drilling. Again, say only drilling. Okay. Now, this will be the way to manufacture the flange. The shaft mainly is going to be done by the turning operation. Turning operation. And we have the impeller. Now, for the impeller can be made by many ways. We can do it by either of course here we have plus, but here we can either do it by the casting, which required to have some machining. And this casting can be done by either the sand casting or it can be done by the die casting. The other way to do it is simply just use the metal deformation processes. Okay, of course, it's going to require some extra work, like, for example, the joining processes. Mainly is going to be the welding. Now, for the body, is going to be done by the casting. And mainly is going to be done by either the die casting, either is going to be also can be done with the sand casting. Okay, now if we're going to go for these operations, these are the simple description for it, but just remember that every part can be done with more than one process. Except the shaft is the only way. So again, to make a star. Now you can see that the impeller can be done either by the casting or the metal deformation. So for the flange is going to be done by the casting. No, maybe it's going to be done by the turning operation, then have drilling operation. So this one once again cannot be done by another method. The material, usually this one is going to be made from steel, and this is going to be made by the steel. We should have to consider that between these two parts, we should have a good tolerances. Okay, which is going to be the critical issue in the manufacturing. Because the flange is going to be sitting inside the shaft. Sorry, the shaft is going to be sitting inside the part. Now for the bodies and the impellers, now we also can have a multiple methods to do that. Now this can be done either from the steel, aluminium, or copper. Actually, it's not going to be cover, it's going to be the brass. For the body, once again, it can be done from the cast iron or from the aluminium. Now, in that case, we can always have the process of the design for manufacturing, how we are going to make the things. Let's talk about the impeller first. If my impeller shape is going to be just a simple one, like we're going to have the shaft going here, it's going to be usually have that shape, and the propeller is going to be that way. So during its rotation, the water will simply pass from one side to another. Other types of the impellers is going to be much easier to manufacture. It's going to be just a plate with a cylindrical part in the middle, and this plate is going to have the fins, which is going to just something going up like that. Sorry for the bad drawing, but actually that's how it's going to be at the end. Okay, and during the operation, of course, these plates again to push the water inside the water pump and cause the movements. If I'm going to make it this shape, which is going to be solid, this definitely is going to be done by the casting. And of course, because we're going to have a hole for the shaft to go through, we need to do some drilling operation. And also we need to do something like the reaming, because the accuracy of the dimension is going to be a very important issue. For here, this part can be done by the machining process. Once again, it's going to have a hole, then it's going to be joined welded here. The plates can be cutted, the whole plate and the plates can be cutted by the deformation processes. Then they're going to be joined together by multiple methods. For example, if I'm going to just have a straight line, I need to do the welding at the bottom. Usually nobody do that. Most of the cases are going to have the cut, which is going to look like uh, that. It's going to have an extension on the side. And they're going to have a spool weldings to fix it on the plate. Okay. Um, the question is, can we machine the plate? Can we machine the plate? I think there is a video on how to um, machine a plate or the propeller for the water pump. I'll just check that. No, it's not right. I just let me get the correct spelling for it. Yeah, because sometimes when you don't use the spelling, you forget it. The impellers. Yeah. So water pump impellers machining. Well, if I can do the machining, definitely this should be done on a CNC milling machine. Oh, what's the problem? Okay, so yeah, so you can see that we can machine these impellers. Okay, we can machine these impellers. Okay, and but of course, every case is going to be different. This one of the cases, yeah. The impellers can be machined. Now, the question can be is, can we do it as a plastic? The answer is no. You cannot make it out of the plastic like this one. This one actually, that's metal, yeah. Um, but we cannot make the plastic one like that because the water temperature in the car engine is quite hot. So this will be damaged very fast. Something like that can be worked. You can see that maybe it's going to be machined. No, sorry, this is the the CMM machine to check the dimensions of the part. Yep. Yeah, that's good. Great idea. Okay, now these are different types of the impellers. Most of these parts has been done by the deformation process. Okay, you can see that's just a plate, and has been cutted, and it has been bended to a different shape to create the shape of the impellers plates. This one is made of brass. Okay, and the others we saw were made of the steel. This one is made of steel, and we can have more which made of the aluminum, like this one. Okay, now we come to the body. Now let's inspect the body briefly. We can see that this part has been made by die casting. Uh, Back in the old days, mostly it was done by the sand casting. Wait a second, let me inspect that. No, I can tell that this one has been done by the sand casting because you can see that the shape here is going to be complicated part to be projected from the mold. So definitely it's going to be done by the die casting. Here come to another thing. We can do something called the design for manufacturing. We need to simplify the things. So we can simply change the design of the body to make it more simpler so we can do it by the die casting. Usually we don't need that. We don't need this part. Okay, this inlet is mainly for the water that for the air conditioning water. So we are going to have sorry for the gear oil cooling. So this water will be simply pumped inside the radiator, which will you choose to cool down the gear pump oil, and then it's going to be recycled once again with this within the same cooling water to drop the temperature. So if I get to simplify the design of that, I can change the manufacturing process immediately. If that shape is going to be sand casting, if I get to remove this part, it's going to be simply done by the die casting. You know that the die casting is going to have higher production rate and the cost within the higher manufacturing times is going to be reduced and thus we can save some money in this process. So both the impellers and the body can be machined, can be made by different manufacturing processes. Each manufacturing process is going to have its own properties and can deal with different metals. And of course, the property of the part itself can last longer. If I can talk about the brass once again, the brass this can be done mainly by casting or machining. The main the main property for the brass is cannot last longer. So we have to worry about that when we're dealing with the water pump. In the other case, if again to work with the aluminium, of course, going to be lighter weight and it can take higher temperature than the high temperature uh, working temperature rather than uh, the brass because the melting temperature is higher. And if I get to compare it to the cast iron, it can resist uh, the corrosion. Okay, because you know that the cast iron, because it's going to have the fluids with them, this can be rusted, and this can damage the impellers of the water pump. The same thing, of course, is going to be for the body. The cast iron can be rusted, and this can be corroded, while the aluminium is going to be last longer life than the cast iron. Um, if I can talk about the weight, the aluminium is going to be the beta. Now, the main disadvantage of the aluminium is going to be the cost. So that's some of the example we need you to discuss in your report about how we choose the material and how to choose the manufacturing processes. Now, if you go actually to uh, the outline of the project, if I'm going to open the outline of the projects, and we need to write down some points about what we need to do in this project. We're going to go through that. The main intent of this project is the application of the theory learned during the semester to a mini problem. And because we know from the beginning of the semester, we learned about the material properties, and we learned later about how we improve these properties and how these properties are going to be the selection criteria key in the manufacturing processes. Later, we learned about manufacturing processes. We learned later about the joining processes, and we also learned about the different materials rather than the metal one. Did anyone thought about, okay, now instead of have the impellers, for example, made from metals, why we cannot make it from the ceramic? Good question. We can do that. Maybe nobody did that before, but you can always suggest that. Can we make the whole body made of the composite material? Yeah, maybe we can try the carbon fibers. The other suggestion we can also talk about is, for example, can we make the body of 3D printing? I don't advise that. But the impeller itself can be done for 3D printing. Now, why we don't make the body out of 3D printing? Because once again, we said that it's going to have some porosity, and we don't like to have the porosity for a part which is going to have higher pressure water pump. But for the plates, it's going to be a problem. So this project is actually designed to give you the moment, actually, the moment where you're going to realize why it's going to be need to learn the theory. In addition, the project work sets you up to the understanding of the studio subjects linked to these technical subjects and may increase your progress in the studio later in the course. I'm going to jump from this one, go to the task. So in this task, by now, I think that most of you has joined the groups over three, and some of the projects were more complicated, have more parts. So I increased it to more than three students. Each group student may select a suitable artifact. Now, the water pump was one of the products. We can also use the car compressor, the compressor for the air conditioning, actually, which have multiple parts. And some students actually choose the different parts. We talked about this one earlier. The selected artifact or the focused main components of the artifacts may be going to be comparable to the gear pump in the terms of the size and the complexity. The artifact may be disassembled using the tools available in the mechanical design studio. Because most of the students didn't get actually an actual part, so we have to miss this part. But if you already had, then this will be great to come to the lab and try to deassemble the parts and take a photo for it. The dimension and the surface integrity of the components may be measured using the equipment available in the mechanical design studio and the metrology lab. And I'm going to be more than happy to take you there to do these measurements. The proposed project plan need to be submitted no later than week 7, and I think that we approved that already. After approval by the teaching team at week 9, the student will be conducted a thorough study by the analyzing of the artifact, identifying the main components, justifying the materials, and developing the manufacturing processes. So what you need to put in your report is going to be the following. First, what is the artifact used for? And how is the market? Now, we say here, for example, what is the quantity may be required for your part? Now, we take in a part, we deassemble, we try to remanufacture it, something like reverse manufacturing. And that's something I suggested that we can go through within the semester by using the experience we had in the for the student in the advanced manufacturing subject. If we're going to manufacture 10 parts, it's going to be definitely different than manufacturing 100 parts and different from manufacturing 1,000 parts. How does this part work? course, I just explained for you briefly how the water pump is working. What is the main components that you will be focused on? And the example we had, we just focused on the impellers, we focused on the flange, and we focused on the shaft and the body. What is the working environment? What is the service lifespan is going to be expected? Now, we talked about uh, now I give you my example and you need to build upon that. In my example, I actually use the water pump, which is working at higher temperatures, try to recirculate the water in the engine. Usually, the expected life of the pump itself is can be unlimited, but for the bearings can be damaged, and also the impellers can be damaged. So we have to expect that the life as severe condition is going to be something about 5 years. Uh, what is the material properties are required, and what material may be selected to meet these requirements? I explained, for example, the aluminium, the cast iron, and oh, by the way, the sheet metal plate of the iron also can be used to make the ampoules, and the aluminium. Uh, what are the dimensional tolerances and the surface integrity required for and again to be critical? Now, the inside diameter or inside hole surface of the impeller should take actually a very close tolerances because shaft will be inserted there. Same thing for the flange, and the flange surface itself because it's going to be fit uh, uh, in the bearings, and also is going to rotate in the body itself. So that's an example about the higher accuracy dimensional parts and a very good surface integrity are going to be required and they're critical. Number seven, what is the fabrication technology may be adopted? You remember the list I talked about for different parts, and this can have the alternative processes. What will be the workflow for the material through the possible factory? Okay, now we'll go to this one soon. What is the material wastage, and what may be the impact of the manufacturer processes on the environment? And finally, what will be the cost? Of course, the material wastage is going to be different from one uh, manufacturing process to another. If I get to cast the impellers, then definitely we're going to waste a lot of material because most of the material is going to be used and it's going to be something like slug. It can be recycled. But in the case of the machining, it's going to have the higher manufacturing waste in the process. If I can do it by 3D printing or the by metal sheet work, of course, I can recycle every wasted material I'm going to have. The highest one is going to be in the case of the machining processes. For the cost, if I get to do the thing by the parts, the impeller once again, or the body by using the die casting, the die casting, if I get to make a mold which is going to cost me $200,000, but I can use it to make 500,000 parts. So definitely this will be more economical than try to make the patterns and do the sand casting time after time. So unless we're going to make 1 million parts, the sand casting is not going to be uh, uh, economical more than the die casting. Uh, now the question is, can we do the parts by machining? You have to search that yourself. The workflow of the material. You can make something like the block shape of the casting for the body. Preparing the material, preparing the mold, preparing the pattern, preparing the core, prepare the mold, prepare the raw materials, do the melting of the process, do the pouring process, leave it to solidify, break the mold and clean it, and take the part and do some extra machining to have the finished part. That's an example about the workflow of the material through the factory. If I can talk about the shaft, again, to have a bar, again, to start to do the machining for it, to have it on the lathe machine, to have it in different diameters, and then we need to do the grinding for it to make it ready for working. Um, For the case of the flange, again, to do the turning operation to have the shape of the flange, then again to take it to a drilling machine to have the holes. Now, once again, as I told you, that every manufacturing process is going to have different costs, and that's what you need to search yourself. Now, what do you need to submit? The assessment will be based on a written report and a short video presentation. Each group needs to organize a written project report by addressing the assessment criteria and the rubric below. Well, again, to go to the rubric soon. There is no strict limitation of the number of the pages. As a reference, we can have something between 15 to 20 pages to be suggested if A4 papers are going to be used with normal margin, single line spaces, and Times New Roman, and the size of 12 fonts are going to be adopted. There should be a single page in the beginning of the written report to clarify uh, the document each team member contribution for the individual marking. Now, I know that you're going to submit the report uh, as group, but once again, every student is going to have a different grade. So this definitely is going to require that all the students need to submit the report individually, the same group report, but individually because we cannot give a different marks if we're going to have the team submission. Every student needs to write down a personal reflection which has 100 words minimum, including the achievements from the projects and how they world doing things differently if they have to repeat the task. Use this framework for reflection. What worked, what didn't work, and will you change it if another opportunity will be given to you? You can set this up to the table if you prefer. Finally, the report will need to be submitted through a Canvas. In addition, a short video presentation, less than 3 minutes, need to be submitted where every team member need to present in this video. Use a typical presentation format like introduction, the body, conclusion, and the summary. Now, definitely if you're going to have 4 members, this video can go up to 4 minutes. When you get this video, upload it to YouTube and just include the link in the report. So now we're going to go to the rubric. Now in the rubric, uh, what is that? The marking criteria. I'm sorry, I need to go to the report again. So the marking criteria. So what you need to have in this report, which weighing about 30% for the group and 10% for the individual are first, the introduction, analysis, and diagrams is going to have the weight of 20%. So you need to describe the artifact, main components, and the use case. Analysis, which is function and the working conditions of each component. Also, the justification of the required tolerances and the service integrity. Diagrams, engineering drawings with the main dimensions of and the surface integrity, referring to the standard if applicable. Now, I'm not sure about what your experience with using SolidWorks, but if you need help with the SolidWorks, I can run during the Monday session some of um, the training on the SolidWorks. Now, part number three, which is going to have the highest weight of 40%, is going to be the manufacturing. First, you need to propose a manufacturing process or operations and brief flowchart. Okay, I'm going to show you how the flowchart is going to work. Detailed description of the process and operations. The required manufacturing equipments. Are there any alternative manufacturing processes or operation, and what are their advantages and disadvantages over the actual one you suggested? Finally, what is the impact of the manufacturing processes on the environment? Point number four, the quality assurance and the inspection. And this referring to the standard if applicable, and this will be taken 10%. Now, one of the quality assurance and the inspection is going to be mainly doing the measurement processes. So you can go back to the uh, to the session of the metrology lab and try to use the names of this equipment to be used for the quality insurance. Finally, the estimation of the manufacturing cost, like the time, labor, and the equipment. Now, when you do that, you're going to talk about a single item, manufacturing cost of single item. If you need to actually use more parts, you can mention that if I'm going to do it by massive production, of course, the quantity is going to increase, so the cost is going to be decreased, and so on. If you're going to have a reference to be used, please add a references list. The short video, which is weighing 30% for the group and 10% for the individual. Now, this will be a comparison of the content, comprehensions and the contents, introduction and the selected artifacts, main components, and the working environments, the justification of the materials, the required dimensional tolerances and the surface integrity, and finally manufacturing processes and its impact on the environment. Just remember that here you don't have to give a full details, but you can say something like what I show in my on my paper. I can say here that the part you can actually showing that in your presentation that this parts can be done by the casting or the metal deformation or 3D printing. For the bodies can be done by the casting, and this casting can be die casting on the sand casting. So just show something like that in the presentation. You don't have to go with too much details. And then we need another part, which is going to be the engagement and the communication, because we need to know how did you work together. Clearly delivered variations, I don't know, and appropriate language for the non-specialist audience. Well-defined PowerPoint slides and enhanced presentation, and the conveyed enthusiasm and captures and the maintained audience attention. Total is going to have 100%, 70% uh, for the first part, 30% for the second part. I think that actually this one is going to have 30 marks and this one is going to have 10 marks. And just remember that 75% is going to go for the group work and 10% is going to be for the individual. So you should expect that you may get less than your colleague in the final mark. Anyway, it's not going to be marked at the end, it's going to be just a grade. So you don't have to worry about this point as well. Let me check actually about other parts I have here. We have the carburetor. I think this will be hard. Some photos for the carburetors I used to have. Now you can see that the carburetors can have the body, multiple parts made together. Now we know how to bend the pipe and we need to do some extra press on the pipe to have the special shapes. Mainly this one is going to be done by the casting. Actually, I should have here somewhere. I didn't open this file for a while, so I don't know where I can find all these components. Actually, the last time I opened this one was last year. Um, this is done by casting. This is a tube bending. You don't have to mention how the pipe was manufactured. Uh, so what else do we have? Do we have an overview here? Yeah, these are some of the components. We have the floater inside. Multiple of the spring was going to be off-the-shelf item. These parts can be done by the casting process. Yeah, most of the parts here are done by the casting and some machining processes to have the final shape. Okay, so well, I don't prefer that we work with this one. I think that this one was for the reverse manufacturing. Yeah, this one was for reverse manufacturing. Actually, we 3D printed this part. Well, this is the carburetor of the motorcycle. It's a Honda motorcycle, and this one was the filter shooter. So we had a filter to be sitting there, and well, I can show you what was the application of that. So actually, is that part? This is the carburetor. This is the engine block, and here we put a sponge, which can be used actually as a filter for the motorcycle air. Again, to show you that even closer. So you can see here we have the filter sitting on the holder, and simply this will purify the air before we can send it to the engine. That's all what we have. Oh, wait a second. I think that I have. No, no, no. Actually, that's just a share folder with my colleagues. Okay, so yep. Now we understand most of the things we have here, and again, that's what we're going to keep explaining to you during the weekly session. And I hope that by the end, we're going to have the opportunity to take you through the manufacturing processes, help you with most of these details, and come out with a good report for everyone. Okay, thank you, and we'll see you next week.